In this lecture, we are going to start the transportation problem. Basically, we will give the introduction to the transportation problem. Transportation problem is one of the most useful and important topics in operations research. If you see, we are producing some goods. So, the goods are being kept at one location or some other locations, and they have to be transported to various cities. Suppose think about a car, a producing company, say Maruti Suzuki, they have some company in Gurgaon and they are producing it at Gurgaon. From there, they are distributing it at various places of India. So, depending upon the requirement, how many trucks they will send to different cities or different location, so that the cost minimizes. That is basically the transportation problem. So, transportation problem means you are transporting goods or commodities from source to destination, where source has some capacity and destination has also certain demands. And I have to minimize the cost of transporting the elements. This is the basic idea of transportation problem, and please note that the transportation problem is a special case of linear programming problem. This we will show. So, the introduction to the transportation problem is one of the most useful operations research problem and is a special case of linear programming problem. Various quantities of single homogeneous commodity are initially stored at various origin. The basic objective of transportation problem is to transport the commodities from various origin to various destination, such that the total transportation cost is minimized. If I have to form the general formulation can be written this. You have some sources, as we have written this thing, which we are denoting as A1, A2, AM. M sources are there, which we are calling as supply units, and you have certain destinations. Destinations we are denoting as B1, B2, Bn, like this, which we call as demand unit. So, you have some sources. From sources, you will transport certain items into certain destination. If you see the arrows, then from source 1, that is A1, I can transport it to B1, I can transport it to B2, like this way I can transport it to Bn. So, from one source I can go to any destination. So, what happens here is that the nodes, whatever we have defined over here, these nodes, we call these nodes as the represent destination and source. Now, the arc I comma j represents the amount x I j is shipped from ith source to jth destination with shipment cost C I j. So, basically what is happening here, from ith source here, from ith source I am going to jth destination. So, whenever I am trying to go from ith source to jth destination, which we are saying as I j, from this we are transporting an quantity of x I j and the associated cost will be C I j. So, effectively whenever you are transporting, you will transport certain, from source to destination, you will transport certain quantity of the product, and there will be certain cost associated with for transporting x I j quantity from ith source to jth destination, which we are defining by C I j. The amount of supply at source I is A I, and amount of demand at destination D j is B j. So, transportation model is based upon the assumption of balancing, that is total demand must be equals to total supply. Please note this one, transportation model is always based upon the assumption of balancing, That is what you have seen in the earlier one. Total demand should be always equals to total supply. So, if a given transportation problem is not balanced, so one can always add dummy source or dummy destination to balance the problem. So, please note that whenever we try to solve one transportation problem, first we check whether the problem is balanced or not. If the problem is not balanced, then we make we add either dummy source or dummy destination to balance that particular problem. We are assuming that AI equals availability, which we call as row requirement, Bj equals demand, which is equals to the, which means this is the column requirement. Clearly, AI should be greater than equals 0 and Bj should be greater than equals 0, where from the original problem already we have told there are m sources. So, I should take the value from 1 to m and there are n destination. So, that j should take the value this one. For balance problem and for feasibility, source and demand should be equal. Therefore, I equals 1 to m a I should be equals to the summation j equals 1 to n b j. So, from feasibility condition type always this should be equal. That means, summation I equals 1 to m a I, this is equals to summation j equals 1 to n b j. So, total source and total demand should be, total supply and total demand should always be same. Also, we are assuming that Cij is the cost of shipping one unit from source Si to destination Dj. So, Cij is the cost of shipping one unit from source Si to destination Dj. Similarly, Xij we are assuming as quantity shipped from source Si to destination Dij. So, Xij is the quantity shipped from source Si to destination Dj, whereas Cij is cost of shipping one unit from source Si to destination Dj. So, or in other sense, we can write down in the tabular form, we have m sources S1 to Sm, we have n destinations D1 to Dn. The cost associated with them will be, can be written as C11, C12 like this way, C1n in the first row, like this way in the mth row it will be Cm1, Cm2, Cmn. And for the columns here we are writing B1, B2, Bn. This B1, B2, Bn represents the demand and A1, A2, Am, as you have seen earlier, we are representing it as availability. So, availability will come as a column at last, A1, A2, Am, whereas B1, B2, Bn are the this one. So, solution of this above transportation problem. What will be the solution? From source S1, in which destination we are sending the items and how much quantity we are sending. So, therefore, your solution of the above transportation problem always will take the form like this. X will be equals to x11, x12, x1n like this way, and last one will be x m1, x m2, x mn. So, that means x11 means from source 1 to destination 1 I am sending x11 quantity. Similarly, xij means I am sending xij quantity from source I to destination j. So, from here it is quite clear one thing, that sum of the columns, sum of the elements of one row should be equals to this A1. Sum of the xij's of second row should be equals to A2 like this, because you are supplying or you are transporting from source to these destinations, and that should be dependent upon the availability, because if the item is not available you cannot send it. Or mathematically I can say that summation j equals 1 to n xij, this is equals to a I, where I varies from 1 to m, or in other sense it will be something like this. Summation j equals 1 to n x 1 j, this is equals to a 1. So, that it means x 1 1 plus x 1 2, the meaning is x 1 1 plus x 1 2 plus like this way x 1 n equals a 1, and I will vary like this 2 to m. Similarly, if you add each column of this, they should be equals to the demand, because whatever is the demand you will send that quantity also, or in other sense summation I equals 1 to m x I j should be equals to b j. That means, if I have to write down 1, it should be x 1 1, x 2 1 like this way, x m 1, sum of all these columns should be equals to b 1. So, please note these 2 points, these 2 always should be satisfied. I want to find out a solution matrix like this x I j, where I j varies from 1 to n and j varies from j to n. Similarly, in that case these 2 conditions 1 and 2 must be satisfied. So, if you think of transportation problem versus the LPP problem, as I told you earlier, transportation problem is a special case of LPP, linear programming problem. So, in that case your transportation problem can be written in this form: minimize z equals c x subject to a x equals b, where what is c? C is your coefficient matrix, this one, C, this matrix is the C. So, I am writing it in this form: C 1 1, C 1 2, C I j like this way, C m n, where C is m n component row vector. What is your x? X is this matrix basically, x 1 1, x 1 2, x 1 n like this. So, x I am writing in the same way, x 1 1, x 1 2, x I j, x m n transpose. Here the transpose will come. So, x is also m n component column vector. Since it is column vector, so you have taken the transpose over here. Your b is written here, a is written over here. Therefore, your b is nothing but a 1, a 2, a m, b 1, b 2, b n. That is, b is your m plus 1 component column vector, and a equals a 1 1 bar, a 1 2 bar like this way, a m n bar coefficient matrix, in which a bar I j is a column vector associated with the x I j. So, therefore, your a x equals b, whatever we have written, minimize z equals c x subject to a x equals b, this a x equals b can be written like this: x 1 1 plus x 1 2 plus x 1 n equals n a 1, x 2 1 plus x 2 2 plus x 2 n equals a 2. Like this way, x m 1 plus x m 2 plus x m n equals a m. Then x n 1 1, x 2 1 plus x m 1 equals b 1, and for b's the last one will be x 1 n, x 2 n plus x m n equals b n. So, x I j appears, if you see, in 2 constraints for I and j. X I j or x 1 1, if you see, it appears in the first row and it appears on this row. Similarly, x I j will appear only at 2 constraints only, not more than 2 constraints. So, they appear in the ith constraint and m plus jth constraint respectively. So, therefore, for each vector a I j, there will be 2 1 and remaining m plus n minus 2 0 vectors. That means, I want to say whenever your x 1 is coming, it will come at ith constraint, that is first constraint, and it will come on the m plus 1th constraint. So, this is your m plus 1th constraint. For all other cases, x 1 1 1 will be 0. So, the cost of transportation, we can write down z equals c 1 x 1 plus c 1 2 x 2 plus c m n x n x m. So, if I have to write down in the matrix notation, I can write down this thing. minimize z equals summation I equals 1 to m, summation j equals 1 to n, Cij xj, Cij xij, subject to these two restriction what I told earlier, summation j equals 1 to n, xij equals ai, and summation I equals 1 to m, xij equals bj, where xij is the greater than equals 0. Since you are transporting the commodities or goods, it always should be greater than equals 0. Therefore, for this problem, this is nothing but a LPP problem. So, thus one transportation problem can also be solved as a linear programming problem. In this case, number of constraints equals m plus n, number of variables will be m n, and this is true for balanced transportation problem. If total supply exceeds the total demand or vice versa, then the summation j equals 1 to n xij, it should be less than equals ai, and summation I equals 1 to m xij should be less than equals bj, where I will vary from 1 to m, j will vary from 1 to n. Therefore, the number of basic variables for this case will be m, number of constraints is m plus n. So, number of basic variables m plus n minus 1. Now, let us see from a problem how to formulate the transportation model. You see one example here, and umbrella manufacturing company, which we will afterwards denotes as AUM, in India sells its 3 products during March to June every year. AUM estimates the demand rate for 4 months March, April, May and June to be 100, 200, 250 and 300 units. So, he is saying the demand is 100 units, 250, 200, 250 and 300 units. The company can vary its production capacity on a monthly basis. The company can vary its production capacity on a monthly basis to satisfy its demand. Because the monthly capacity does not match with the monthly demand, the current month's demands can be satisfied in 3 ways, that is current month's production, surplus production from earlier month, which I said lead time demand, that is I have produced more and the demand was less. So, surplus production from earlier month or surplus production from later month, but I have to meet the demand. So, I can meet it from current month's demand, I can meet it from surplus demand from earlier month or surplus production from the later month. In the first case, production cost per umbrella is rupees 100. So, please note that if you are producing and you are delivering it in the same month, your cost of the umbrella is 100. The second case, that means you produced in the earlier month and you are delivering it in the next month. So, you have to keep that umbrella for 1 month. So, we are adding one additional holding cost of rupees 5 per umbrella, or in other sense, whenever you are meeting the demand from surplus production from earlier month, your price or production cost will be rupees 105, whereas this was rupees 100. In the third case, a penalty charge of rupees 10 per umbrella per month is incurred for each month of delay. That means, whenever basically you cannot supply the demand, then you are supplying it in the later month from surplus production, then you have to pay a penalty. That means, your production cost will become 110 plus 5, that means 115. So, the meaning of these 3 are this, that you are producing certain quantities and you know what is the demand, that is March, April, May and June, it is 100, 200, 250 and 300. If you are meeting the demand in the same month, cost umbrella is 100. If you made surplus production and meeting it in the later month, in that case you have to add one additional production cost, that is additional holding cost of rupees 5. So, your original cost was 100 and you are adding rupees 5. So, cost of the umbrella in this case production cost will be 105, whereas if you are meeting the demand from surplus production for later month, in that case you have to pay an penalty. Pay and penalty means your cost was 100, then 5 since you cannot pay it on the same month, and plus 10 the penalty. So, cost or the price is 115. It is estimated that AMU can manufacture 120, 180, 280 and 270 units in March through June. That means, the estimated production quantity from March to June is this one: 120, 180, 280 and 270. Now, Cij, we are assuming production cost in I, that is I equals j, and production cost in I when I less than j, and this is I greater than j. As I have told, that is I equals j means you are meeting on the same time. If you are not meeting it in the same time, then it will be 105, and whenever I greater than j, in that case it will be 115. So, what will happen? 1 to 1, from here you see, from 1 to 1, that is here I equals j. So, it will be 100. Whenever 1 and 2 I is less than j, so there will be an increase of 5 rupees. So, it will be 105. Again 1 3 I is less than j, so it is 110. Then it is 1 4 I is less than j, so therefore, it will be 115. Similarly, for 2 2 whenever you will take, for 2 to April 2, this will remain 100. Now, for 2 1 it is I and j. So, it is greater than, therefore, this will be 110. Again 2 3 I is less than j. So, it will be 105. Again 2 4 I less than j. So, it will be 110. For the third row and third column, that is here and here, this value will be 100. Whenever 3 greater than 1, this will be the highest penalty, 120, 110, 100 and this will be 105. This you cannot produce, you cannot give, since I is greater than j in this case. So, in number 4, again 4 and 4, it will be 100, and here it will come 130, 200, 130, 120, 110 and 100. It is reducing by 10 rupees, because for all these cases, whenever I is greater than j, you are giving a penalty of rupees 10, and whenever I less than j, in that case you are giving additional holding cost of rupees 5. That is the reason your, and for this case it is 0. So, depending upon I less than j, either you are adding 5 or you are adding 10 whenever I is greater than 0. So, like this way, here your monthly demand has been told as, production capacity we have told here, it can estimated manufacture this many quantity. So, this will be 120, 180, because this represents the monthly month and this represents the year. So, 120, 180, 280 and 270. Whereas, monthly demand you can obtain here. We have already told what is the monthly demand. Monthly demand is 100, 200, 250 and 300. So, therefore, here monthly demand will be 100, 200, 250, 100, 200, 250 and 300. If you add these 4, then we will see that the sum of these 4 are same. That is, sum of these rows, these columns elements and sum of these will be same. If this is same, then we call it as a balanced transportation problem. If it is not same, then we call it as the unbalanced transportation problem. So, now we will see how to find out the solution. First, we will find out initial basic feasible solution. Afterwards, we will check whether that solution is optimum or not. Let us see the first problem, first method, which we call as northwest corner rule. In the northwest corner rule, what we do? Allocate maximum allowable amount to the northwest corner of the table. That is, maximum allowance amount equals maximum of availability A I and requirement B j. In step 2, the allocation process is continued until all the available quantities are exhausted and all the requirements are satisfied. So, we are allocating maximum available amount to the northwest corner of the table. Then in step 3, the cells corresponding to the feasible solution or a subset of them do not form a loop, and then it will be a basic feasible solution. We will see later. Please note that such a solution may not be optimal as the cost were not taken into account at all. Here we are just checking the availability and the requirement, that is supply and demand, but we have not considered the cost at all. Let us see one example, it will be clear to you. Suppose you have a problem like this. These are the, it is given over here. So, I am just writing here 19, 20, 50, 10. You will write like this 70, 30, 40, 60, 48, 70 and 20. Here availabilities are given, here your this is given 5, 8, 7 and 14. If you see 7 plus 9 plus 8, the sum of these three, 7 plus 9 plus 8, this is equals 34, and the sum of 5 plus 8 plus 7 plus 14, this is also 34, or in other sense summation over A I, this is equal summation over B j. So, the problem is a balanced transportation problem. So, you start from left northwest corner, that is you start from here and proceed like this way, one after another. What I am finding for this, on this case your this value is 5 and this value is 7. So, A I B j minimum of these two is 5. So, allocate this 5 to this cell. So, now this will be 0, because this is becoming 0, this 7 reduces to 2. Now, go to the next one. In the next one, minimum of this availability and demand is 2 and 8 is 2. So, therefore, allocate 2 over here. So, that this becomes 0 and this becomes 6. This becomes 6. Now, you see in this row already whatever the availability was there, that I have given 5, 7. So, forget about this row. Now, come to this row. On this column already whatever demand was there, that you have satisfied. So, you do not have to allocate anything on this cell. Here I am finding on this cell, if you see, now your demand is 6 and availability is 9. So, minimum is 6. So, therefore, you can allocate 6 at this cell. So, this will become 0 and this will become 3. So, now you go to the next row. Here it is 3, here it is 7, available 3, demand is 7. So, minimum is 3, you can allocate 3 to this one. So, that this becomes 0. So, you do not have to do anything for this case also. Now, come to the next row. For this always already you have made the demand, because this is 0. For this element you have made it 0. Here it is 7 and it is sorry, it was 7 whenever you have given, it has become 4. From here whenever I have given this, it will be 4. So, when I am meeting this one 4 and 18, so you can allocate 4 at this position and the remaining this becomes 0, this 18 becomes 14, only one cell left. So, now you can see this 14 I have made. So, I have made the allocation like this. So, like this way, whenever you are giving this one, you see for each case I have made the allocations. So, your total cost your can be 5 into total cost. If I can calculate, it will be 5 into 19 plus 2 into 20, that is you are counting the cost only on the allocated cells, plus 6 into 30 plus 3 into 40, this one plus 4 into 70 plus 14 into 20, and total value will be 995. Because same problem what we will do, we will try to solve by some other way. So, basically you are starting from the leftmost corner, leftmost cell, and from the leftmost cell you are allocating depending upon which one is the minimum of AI bj, AI comma bj, and you are going on doing it this process. So, this process is simpler. Like this way various other processes are there, techniques are there, but only thing remember, the allocation is correct depending upon the availability and the demand, that is summation over AI equals summation over bj is satisfied. It does not mean that the cost will be optimum, that we will see later.